Okay, this is lesson 2.3, shortest distance and its applications. In this video, we're going to find the shortest distance between a point and a line, and when we do that, what we're doing is we're finding the altitude. Now, it's easier to describe what an altitude or shortest distance is if we look at geometric shapes. So on these three shapes, I've drawn on the altitudes. And if you look, the altitude is just the height of the geometric shape. So it's from one side to the other. The key is that it intersects the other side at a right angle. So if we're going from a point to a line, this would also be the height of the geometric shape. If we're looking at a triangle, we could find the height of the triangle from any of the points. The one I've drawn on is from here, all the way down to the other side, crossing at a right angle. If I drew it from a different point, like this one, I'd draw it from here, and it would go all the way across to the other side, to wherever on that other side, we would make a right angle. The key is the right angle. So if we go from this point, it's not going to necessarily be centered on the other side, it's going to be somewhere on the other side that would make a right angle. So that's the height of a geometric shape. It's from one side, or one vertex, to the other side, crossing at a right angle. It doesn't necessarily go through the midpoint of the other side. It goes to wherever it would make a right angle. And that is the shortest distance from this point to this line. There's no way we can get shorter. Any angle we take that's not 90 degrees will be slightly longer because it would be like the hypotenuse of the right angle triangle. The shortest distance would be crossing the other side at a right angle. To illustrate this, we're going to do an example of finding the equation of an altitude, and then we're going to use that idea to find the shortest distance. So let's look at our first example. Draw a triangle ABC with the vertices A, B, and C. Then draw the altitude from vertex B and find the equation. So let's start with our triangle ABC. First point's -5, -4. So graph that, -5, -4. Grab the A. B is -3, 2. And C is 5, 1. Oops, 5 is on the other. And there's our 3 points on our triangle. I'm going to connect them with a ruler to make a triangle. With a ruler. Yes, I do have a ruler. A, B, C, and AC. All right. Now, if we're drawing the altitude from vertex B, that means it's from here to this line intersecting at a right angle. So if I draw that, try to cross it at a right angle. Let's see what we got here. And I'll draw the right angle symbol on there just to show that that's definitely a right angle. If I missed it by a little bit, it's okay. We're just graphing. And we can't graph it perfectly because we don't have the equation, but that's what it would look like, from B to the other side at a right angle. So how would I come up with the equation of this line? Well, on this line right now, I know one point for sure. I know point B, and I don't know the slope of the line. It looks like it touches that point right there, but we can't assume because we drew it roughly. So what we can do is we can use the idea that this line should be at a right angle to this line. And if you remember back from grade 9, we have a property that says if two lines cross at a right angle, they're perpendicular, and that means their slopes will be negative reciprocals. So what's that mean? Well, that means if I know the slope of AC, I can find the slope of my altitude by taking the negative reciprocal. So let's start by finding the slope of AC. And remember how to find the slope. It's y2 minus y1 over x2 minus x1. My points are A and C, x1, y1, x2, y2. And the slope formula is y2 minus y1. So it would be 1 subtract negative 4 over x2 minus x1 is 5 subtract negative 5. And if we do some careful math here, we've got 1 subtract negative 4 is 5 over 5 subtract negative 5 would be like add 5. 5 plus 5 is 10. 5 over 10 is just 1/2. So that's the slope of AC. We don't want the slope of AC, we want a perpendicular slope. So we can do the upside down T to signify perpendicular. And the way you find a perpendicular slope is it's a negative reciprocal. Negative means change the sign. This sign's positive, our new sign is negative. Reciprocal means flip the fraction. Instead of 1 over 2, we get 2 over 1. So the slope of our altitude is negative 2. Now we can start to write the equation of our altitude. We know it's going to be a y equals mx plus b. We just figured out that the slope is negative 2. We all now need the y-intercept. If we trace this line forward, it looks like the y-intercept's like maybe negative 4, but we can't assume, so we can calculate it. We know b has the coordinate negative 3, 2. So we can use that as our x and our y. 2 for y, negative 3 for x. And we can solve for b, just like we did earlier in the unit in the review lesson. Do a little bit of math. We get negative 2 times negative 3 is 6, plus b equals 2. Bring the 6 over, we get 2 minus 6. 2 minus 6 is negative 4. So we were right, the y-intercept is negative 4. So therefore, our altitude from B is y equals negative 2x minus 4. All right, so that's how we find the equation of an altitude. Now, this lesson is about shortest distance. Once you find the equation of an altitude, you can use this equation to find the distance from B to this line. And that's 2 more steps. So we're going to do that example next in example 2. Let me read to you about shortest distance. The shortest distance from a point to a line is found by making a perpendicular line from the point to the line segment. That's an altitude. And once you have the altitude, you can find the shortest distance, and I'm going to show you how. So let's look at our example. A cabin is to be built near a straight road that connects campground A and B in a park. A new side road will connect the cabin at C to the existing straight road. Find the shortest distance from the new road to the cabin, new road from the cabin to the straight road. A lot of stuff that we got to look at here. So there's a road that connects 2 campgrounds A and B. So let's come up with a sketch of this, a rough sketch. We got A and we got B. I'm going to start just by putting A up in this corner. A is 2, 9. Our next point's 10, 5. That's further to the right and down. Put that, oops. Put that right here. B, and that would be 10, 5. So here's our road. There's another cabin C at 6, 2. 6 is between 2 and 10, and 2 is even lower. So I'm going to put that right here. Call this C. That's 6, 2. And we're going to make a road from here to our line. And if we want the shortest road, we have to draw an altitude. So it has to cross here at a right angle. So we want to find this distance from here to here. The thing is, we don't know this point. So here's how we find that point so we can calculate the distance. And this is the step for every shortest distance question you're going to do this year. start by finding the equation of your line, your original line. So in this case, it's AB. Then, find the equation of your altitude. In this case, it's C to, call this point D. So AB is the original line, CD is our altitude. Once you know the equation of two lines, if you want to find this point where they cross, that's the POI. And the POI on that picture is D. Once you find the length of the point D, then you find the length of the line, CD. So 4 steps, all using stuff that we've learned this unit. Equation of a line, equation of an altitude, which is what we just did in example 1. The POI, which is what we did all last unit. So we're going to use substitution and elimination. And then the length of the line CD, which is what we did in lesson 2.2, find the length of a line. So 4 steps. So let's start with step 1. Step 1 says find the equation of A to B. Well, we got to start with slope. Slope of AB is y2 minus y1. So we'll start with y2. 5 minus y1 is 9 over x2 is 10 minus x1 is 2. 5 minus 9 is negative 4. 10 minus 2 is 8. We get negative 1/2. That's the slope of AB. Once we get the slope, we can use our slope and point A or B to find our y-intercept. Y equals mx plus b. Slope is negative 1/2. I'm going to pick, maybe let's do point B, 10, 5. 10 for x, 5 for y. Negative 1/2 times 10 is negative 5. Bring the 5 to the other side, we get 5 plus 5. 5 plus 5 is 10. So there we have M and B. Write the equation of our line. Therefore, y equals negative 1/2 x plus 10. So there's our equation of AB. Now we got to find CD. Step 2. Well, as we saw in example 1, the slope of CD is going to be the negative reciprocal of the slope of AB. AB's slope is negative 1/2. So if we want our slope, we want a perpendicular slope. That would be change the sign, so plus, flip the fraction, 2. And now we use the equation in a point. Our equation will be y equals mx plus b. We just found the slope is 2. The only point we have on this line right now is 6, 2, so that's what we have to use. 6 for x, 2 for y. 2 times 6 is 12. Move the 12 over, we get 2 minus 12. So b is negative 10. So therefore, y equals 2x minus 10. So now we've got the equation of our line AB. We've got the equation of CD. Now we need to find the POI. Step 3. Find the POI. So we have 2 strategies. We can use substitution or elimination. If we look at our 2 equations, they both say y equals. So that means the coefficients on y are the same. We could do elimination fairly easily. Or we could do substitution. we could take what y equals, 2x minus 10, and replace it where y is in the other equation, and then solve. It's up to you whether you do substitution or elimination. I'm going to do substitute. Let's do elimination. Y equals 2x minus 10. Y equals negative, I'm going to use the decimal, 0.5x plus 10. I think that'll make it easier to do the elimination. Since the numbers in front of y are the same, I'm going to subtract. Let's see what we end up with. Y minus y is 0y. 2 subtract negative 0.5 would be like plus 0.5, so it's 2.5x. Negative 10 subtract 10 is negative 20. The y was eliminated. Move the 20 to the other side. 20 is 2.5x. Do a little bit of math here. 20 divided by 2.5 is 8. So now we've got x is 8. Let's plug x into one of our equations to find y. I'm just going to use the second equation. Y equals 2 times 8 minus 10. 2 times 8 is 16 minus 10 equals 6. Therefore, the POI is 8, 6. 8, 6. So now we know the coordinate of D. 8, 6. And that leaves us with one more step. Step 4, the distance. So we've got our 2 points. So we've got C and D. C is 6, 2, and D, the point we just found, is 8, 6. So if we want the distance, we got to use the distance formula. The distance of CD is the square root of x2 minus x1. So that's 8 minus 6 squared plus y2 minus y1 is 6 minus 2 squared. So that's our distance formula from the last lesson. Do the subtraction. We get 8 minus 6 is 2, so it's 2 squared, plus 6 minus 2 is 4, it's 4 squared. A little bit more math, 2 squared is 4, 4 squared is 16. So we end up with the square root of 20. And that's a nice exact answer. If you want the decimal, we do square root 20. We get 4.47, and we'll round that to one decimal place and call it 4.5. And does it say kilometers? It doesn't say any units in the question, so we can just leave it as 4.5. All right, that's a lot of steps. So shortest distance is probably actually the longest series of calculations that you're going to have to do in this course. So we're going to practice it a lot, but these 4 steps will work every time. And separately, these are 4 things that you know how to do. Find the equation of a line, find the equation of a perpendicular line, solve a system of equations using substitution or elimination, and then find the distance between 2 points. Separately, the steps aren't super challenging. It's just remembering the order to do them in and how to do them all together is the tricky part. So we'll do a lot of practice with shortest distance in class before we get to our test. And that's it for lesson 2.3, shortest distance. Thanks for watching, and I'll see you next time.